This is the top floor manifold fitted with no air vents, so there's a problem with circulation here. One, because of air trapping in the system. I've actually reduced the amount of air by bleeding air out of this nut, opening it with a spanner. You can see some cloths down there to catch the water that's come out. Also, the pressure at the boiler was down to 0.7 bar, so it's not enough to force the water up 4 floors. I've increased the pressure to 1.75 bar, and this is allowing now the water to actually be raised up to this top manifold and circulated around. I don't know if the camera's picking up the sound, but you can hear the air gurgling in the system, and an automatic air vent really is needed here. Did originally suspect this was a manual air vent, but it's just actually an adjuster for a loop which isn't in use. We'll see what we can do, see if we can fit an automatic air vent in there and get that all working. Here we are on the ground floor manifold. You can see there the automatic air vent and a drain cock fitted on this manifold. That prevents the air build-up that we're suffering from on the top floor and allows the water to circulate without any resistance. And hopefully we'll be able to copy that layout and get the valves to suit to adapt the manifold upstairs. As you can see, there's one on the top and on the bottom. Although they're automatic air vents aren't meant to be left open. They're meant to vent the system in the first place and then be closed. And you can see on this bottom one that's actually been leaking where it's been left open. And that top one actually looks like it's leaking from where it joins into the manifold rather than at the automatic air vent itself. These are the lower ground divicons. These control the temperature of the underfloor heating on each floor. The first one here you can see with the grey box at the bottom controls the lower ground floor of the kitchen. This, when I first arrived, I was told worked okay, and the pump setting on this floor was set at number 3, which is the fastest speed. Along to this one, this is the top floor. If you can pick up the sound, you can hear all the air in the system. This is a system with no automatic air vent on it, and I'm not quite sure why we're getting noise at the pump, and need to investigate that further. But as you can see, I've adjusted the gauge here to the pump speed to number 2, and if we look up at the gauges, I don't know if you can see that, we've got 38 on the flow and 30 on the return, which is about right, about 8 degrees, should be 7 degrees ideally. Ground floor we've got 40 and 38, only 2 degrees difference, so maybe that pump's running a little bit too fast actually for the ground floor. Next floor along, this is the ground floor. You can see we've got 40 and 40. An average temperature on the floor of 40 degrees, which is unlikely. The last one along, the valve is actually closed. We've got quite low temperature on the flow and not too much temperature difference. This suggests to me that the heating curve is set up incorrectly for this floor, and that the floor is running at a lower temperature, which would be normal if we had maybe a tiled floor and not a timber floor. And I'm told it's timber floors throughout, and in fact I haven't seen anything but timber floors except for in a little wash area just outside the boiler room here. As mentioned on the previous video about the top floor, the pressure was very low in the system, and this is our filling loop down here. It's just below our header here. I'm not sure if it's actually a low loss header, but it's certainly a header. And here's our filling loop. The pressure in the area is quite low though. I haven't been able to get it above 1.7 bar, and I would have pressurised it higher to try and reduce the impact of the air in the pump for the top floor, if I could get it to go a little bit higher. But maybe we need some sort of pumping kit on there to raise it higher if we need to. But for now we'll stick with what we've got. Temperature on the on the solar heating cylinder was set at 60 degrees, and the Viessmann boilers don't like that. They have trouble reaching 60 on the hot water, and they come defaulted at 50 degrees. Probably been turned up due to the fact there's been not enough hot water to satisfy their customers' needs here. only half this cylinder, which is about 150 litres, is actually heated, and that's quite a small quantity of water for such a big house. And I'm going to be looking at ways of maybe being able to heat the bottom of the cylinder when there's no solar to take advantage of. Not quite sure how I'm going to do that, but I'm sure I can work out a way, and I'll put that forward as an option. So, okay, this is the expansion vessel for the heating system. This basically takes up any expansion in the water as it's heated. It's got a rubber bag inside which is pressurised with a charge of nitrogen through a Schrader valve on the top, which is the same as one you get on a car inner tube, or a car tyre these days. No inner tubes in them these days. There's a pipe that connects that into the heating system, and that has an isolation valve on, so when it comes to servicing the valve can be turned off. But we need a drain point here so that we can drain the excess pressure out safely. At the moment I could do it by undoing this nut, but it'd be better to have a proper drain cock in here so I can drain the water out well. So that's one of the little jobs we should put on our list. What should be happening is the water should be coming up this pipe and either flowing through this one or circulating back and going back to the boiler this way. It's a 49 kilowatt boiler, much too big for the property, so I'm expecting it to send water back this way and circulate round, but it doesn't seem to be doing. This temperature on this return is very low. The boiler's cutting out over 80 degrees, and this pipe isn't reaching 80 degrees or anywhere near it, and this one certainly isn't responding. And also, if I was getting a flow of 80 degrees here, I would expect to see, with these valves open here, as you can see the valves open on the mixing valve, I would expect to see on this gauge here a temperature also of around 80 degrees, or certainly higher than 40, but that would depend on the flow rates. So a few more tests on that, and we're going to prove there's a problem with flow on the boiler, or not. And also I'd like to prove that these can actually cause an overheat to the floor if the boiler isn't set up properly. The settings in the boiler weren't quite correct either. I wasn't happy with those. There is a means in this boiler to set the top flow temperature limit to 55 degrees, which would be the maximum flow temperature allowed for an underfloor heating system. Also, if you notice now, I pressurised the system to about 2 bar. It's risen to 2.5 bar now, which is more than enough to get water flowing to the top floor, and that's probably because of a lack of servicing of the expansion vessel. It's probably quite flat, although I have left the filling loop open continually during the job to try and get the pressure up, but there didn't seem to be the pressure available in the street, so it could be either or, their expansion vessel, or we actually did get the pressure in the street. Either way, that's going off now. Still getting a problem with noise in my pump though, which I was expecting to cure by getting the pressure up higher, so I'm not quite sure why we're getting that problem there. Maybe there's some problem with flow in that system as well, but further investigation required. Okay, this unit here is called the 200H controller. I've labelled this up so now we can see, or maybe we can't see, that button 1 controls the ground floor conditions, button 2 the first floor conditions, and button 3 the second floor or top floor conditions. And you select the circuit from the buttons on the left hand side that you want to actually program, and then control it from the read out what you're doing from the centre display panel. I've adjusted the heating curves for the upper floors. They were set quite low. The ground floor, basement floor rather, that was reported as working well was set higher than the other floors, so I've adjusted those up to match, and hopefully we should get some results from that. This unit actually controls the mixing valves next door. So I come through. The first valve, the big grey one, is controlled directly from the boiler, and the settings for that are in the boiler. The next one here and the other two here I've labelled. You can't read the labels I don't think in the film, but I've labelled up which one corresponds to which slot on the 200H. Everything seems to be working well as far as these controls are concerned. I've managed to get the pressure up on the system very high, just to clear some air, to 2.5 bar, which is higher than it actually wants to run at, but will do for now to remove the air. Of quietened the pump, seem to have good circulation on the top floor. In fact, we've got very good circulation on all the floors. Might be a little bit higher than the design temperature for the floors, but actually that's not necessarily a bad thing. It'll just give us a slightly higher heat output from each of those floors. So I think with what I've done, we should be halfway there. A bit of insulation on the top floor should help, and also I seem to have a problem with the boiler overheating. So if I go into service mode here on the front, you can see the temperature is actually quite high. That'll put the boiler into full output. So the boiler's going to run at 49 kilowatts, much too much for this house. But what I would expect to happen if I do that is for the water to circulate down through the header and return to the boiler, and not result in the kind of temperatures that you should see in a second or two. And if it does have a tendency to overheat, it will probably indicate that we've got a problem with dirt in the boiler, and that's a fairly straightforward process for me to descale the boiler and get that working properly. And there we go, boiler's just switched off. I've heard the relay go. There we got a temperature rise. Well, it's behaving a little bit better now than it was earlier. It's suggesting a little bit of a flow problem